So my presentation is on peritoneal dialysis. Most of you have maybe heard about dialysis, but this one's not as common, and there's a couple of reasons why, but to go ahead and start, we've got to have some background information. So this is kind of what we'll go over. So at the end of my presentation, you'll kind of understand a little bit more peritoneal dialysis and what it does. And as I go ahead and go through, I want you to go ahead and think about a story. Think about a road trip, and we'll get more into that. But you're just going to go on a trip with me, and it'll make more sense. And I hope you guys get something out of this, whether whatever degree you're getting into, because there's lots of people in the community that actually have to go through this every single day. So, your kidneys, most people when they think about kidneys, they either don't know anything about them or they know just a little bit that they make urine. But they're actually a lot cooler than that, and they're very complex. So when we talk about dialysis, we usually talk about dead kidneys or kidneys that just don't work as well. So some interesting facts is that you have two of them. You can go ahead and live without one, or you can live with one. They're usually found in your back part, in your flank area. They actually help with blood pressure. So a lot of these people that don't have kidney function, their blood pressures are way up or way down. They also help with hormone secretion, so red blood cell production. They go ahead and help with, so you're not anemic, so you actually have good oxygenation. Other things is we consume, or our skin actually takes in vitamin D, but it doesn't do any good unless you have kidneys. So if you don't have kidneys, you have to get active form of vitamin D. So the kidneys actually activate your vitamin D. And some other things, they help regulate calcium and other molecules within your body. So it's just not urination. It's pretty important to know that. So the trip I wanted you to go on with me is we're going to go through tubes, and we're going to go through ducts, and I'm going to tell a little story, but the major things I want you to know is sodium is a huge part of our body. It's kind of like the driver of everything. And to go ahead and focus on a few of them, just remember sodium, potassium. You know, everyone talks about this has a lot of sodium in it, this has a lot of potassium. Chloride we won't go too much into, and magnesium, but just realize those two major ones, and then also urea. So urea we produce because we break down proteins, and which goes to amino acids. Amino acids produce a lot of ammonia, and then we can't secrete ammonia. It's very toxic, so we go ahead and put it in urea form. And we got to get that out of our bodies, so that's pretty important for our bodies so we can get all the toxins out of our bodies. And one interesting thing I found out about, so this is a take-home message, is birds and reptiles do not urinate. They actually go ahead and have, like if you go ahead and get to your car after this presentation and you see the white streak that the birds leave, that's actually uric acid. So that's how they get rid of their urea. So they don't produce urea, they actually have uric acid and they poop it out. So yeah, take-home message there. Important for our bodies to know is water and urea, they kind of go hand in hand. So if you've taken chemistry, you know that you've got water is a polar molecule. So you can see in my, up there, you've got the water, H2O. The O is slightly negative, and the hydrogens are slightly positive, which attract other molecules. And we can say that's the big brother of this slide. And urea is kind of like the little sister. So the brother wants to go ahead and get away from the urea, the little sister, and the little sister loves to go ahead and tag along. So anywhere that water goes, urea will follow right behind. And it'll make more sense as we go through. So still some more background information. When your blood goes to your kidneys, the actual red blood cells that you think of don't actually go into your kidney. It doesn't go into the collecting duct. So the story I'm about to tell you is you've got beau. You know, if the girls have beau, they love to go ahead and meet up with their beau, and the girl's name is glow. So you got your glomerulus, which is the blood that goes into your Bowman's capsule. So glow meets bow, and then they go on a trip, and they go ahead and instead of the blood has the plasma in it, and then the plasma turns into filtrate. So inside the actual nephron, which is the functional part of your kidney, it's called filtrate. It's not urine yet because you still got a lot of things going on. And then it goes into urine after that. So that's filtration. So from the blood, it goes into the glomerulus, which is called filtrate. Reabsorption. So as some of the blood or some of the plasma goes inside the tubules of your nephrons, it actually, some of the molecules realize they shouldn't be in there, so they get reabsorbed. So it's the filtrate that goes back up to the blood. So it's still communicating with the blood, not actually touching the blood. And then secretion, that's actually some of the stuff that actually went back into the blood, went back into the filtrate. So it's just going back and forth. That's all it's saying. So this is kind of what I'm talking about. So this is our road trip. So you've got glow that meets Bowman, and it turns into filtrate. So some of the toxins we were talking about is we've got your sodium, your potassium, urea, water, glucose. All of that goes into the filtrate. All of that goes in the ducts. So you can see right here, it's kind of cut in half. You've got the proximal convoluted duct or twisted. That's the reason why you have it go up and down. It's just twisty and windy. And as that happens, you've got glucose in there, and glucose realizes, oh, I went on the wrong track. I've got to go back up to the blood. So that's the reason why when you go ahead and urinate and you go to the doctor, you shouldn't have any of the glucose found in there. It should all be reabsorbed. And then potassium and other molecules are constantly going back and forth. They're trying to decide, should I be in the blood? Should I be in the filtrate? Should I be in the blood? And they're going back and forth, back and forth. And then as you continue to go on this road, you go to the loop of Henle. And as you go further down to the loop of Henle, you get an osmotic pressure or bigger amount of pressure that pushes those molecules back and forth, to be able to make that pressure gradient. And as you keep on going, you got your distal convoluted tubules. So take-home message is once the blood turns into filtrate, you've got molecules going back and forth all the time, back and forth. And then finally, once it actually hits the collecting ducts, it actually turns into urine, and that's when you urinate it out. Some interesting facts is 99% of the water that goes through there actually gets reabsorbed. So you've got several different processes there. And then urea actually just continues to, you've got your cortex and your medulla, so the lower part of your kidney. It actually, and this is what I was talking about with a sister, the water goes down to the collecting ducts and then sneaks back in to the loop of Henle, and it keeps on going back and forth, while the urea actually gets stuck in the medulla and doesn't know where the big brother went. So it's just a continual round of trying to catch up with the big brother. Really quick, diffusion, osmosis, hypertonic, hypotonic. Here, my friend SpongeBob, he's got a hypotonic solution, and if you don't have kidneys, your blood becomes hypertonic. And just like if you go ahead and put a little tiny drop of colored solution into water, it diffuses. That's kind of the same concept. You put the hypotonic solution inside your body, and you're able to go ahead and diffuse all your toxins outside of your body. So, and osmosis is just the movement of water during that process. Some take-home message is you would think with dead kidneys or kidneys that don't work as well, you should just be able to get a new kidney. But statistically showing in 2013, 30% of people who have end-stage renal disease actually get a transplant, a functional transplant. And then 70% have to go a different route, either pass away or get on a machine or peritoneal dialysis, either until they get a transplant or just get it put on dialysis for the rest of their life. There's two forms. There's centers where they do hemodialysis, or you can do it at your home, or which is outside of the body. They clean the blood outside the body. Inside the body, they go ahead and bring the dialysate, or the fluid that's the hypotonic. And just wrapping up, important things to know is that you have a tube that's surgically implanted inside your abdomen that stays there for the rest of the time you do dialysis until you die or until it stops functioning. So you've got the fluid, the hypotonic solution going in, stays there. It's called a dwell time, 2 hours, 3 hours, and then taken back and out. And hemodialysis, they go to the centers 3 days a week. It's really hard on the body. This is more like a functional kidney, 24 hours, 7 days a week. You do it day in and day out, or they have what's called a cycler. You're able to do it while you sleep. And then all the dirty stuff and with the water actually leaves your body. And just like SpongeBob here. So thank you for your time. And any questions? Good question. So the question was, can you be on dialysis the rest of your life? Yeah, so there's actually, I got into this because I actually worked at a hemodialysis center, and we actually had a gentleman who had 33 years of dialysis. He tried to get one kidney, it worked for 6 weeks, and then another time and it worked for 6 months. And he was able, he got married. His proposal was, will you marry me, but I'm going to be on this machine for the rest of my life. That's kind of how the proposal worked. But he was able to have a kid and live a normal life. And it's actually probably the best organ to lose, because I'm sure lots of you may even know someone on dialysis, and they have good days and they've got bad days, where someone who has a heart problem or a lung problem or something, they're always sick. But these patients, lots of times they can have roller coaster effects, feeling really good and then feeling really bad. So did that answer your question? Yeah. Yeah. Oh, yes.
So the tonics that are used for hemodialysis, do the tonic, like the solvents that hold up that tonic, is it kind of vary from person to person if it needs to be determined beforehand? Or do they just use a universal solvent?
They use a universal solvent. The only thing that actually changes, especially in peritoneal dialysis, is the dextrose amount. So just like what I was talking about with the loop of Henle, the further you go down, the higher pressure gradient happens. And so you've got 3 different solutions in general of dextrose, which causes that osmotic pressure. And so you're actually able to pull more fluid with a higher concentration of dextrose, since it's a bigger molecule, versus one that's lower. So, but yeah, for the most part, the sodium, potassium, chloride, magnesium, they're all a lower level. And whatever your body, so not only do the solutes that are bad for your body go out into the peritoneal dialysis fluid, but some of them will go in. So for instance, antibiotics, you can put antibiotics in the fluid, and that actually will get reabsorbed inside the body. So. Just really quick, one of my last slides, limitations. Even though this helps with fluid and toxins, just like with your vitamin D, phosphate binders, other things your kidney does, you have to get shots or you have to take pills to be able to reproduce what the kidney does. So. Okay.